This is the penultimate lecture. It's going to be a shorter one than last week's near 75-minute long spiel about collections. Today we are talking functions. There's going to be a lot of review here, but where before we talked about how to use built-in functions that are provided to you by Python and its associated libraries, this time around, we're going to talk about creating our own functions, why that's important, what makes it so powerful. We're going to look at some other keywords that we've kind of sort of touched on throughout this class, but not in entirety. And then we're going to look at some examples, and lastly, we're going to talk about lambda functions. We are going to skip over the examples in this video because we will be doing those in later videos. So, getting straight into it. What is a function? Remember back to the early lectures that a function is a reusable piece of code that accepts some input, can accept some input, and produce some output. Why we use them? They're the backbone of dry code, dry standing for don't repeat yourself. If you find yourself using a function or a piece of code more than once, you might want to turn it into a function. In some cases, if you just think that it would be useful elsewhere, you might want to consider, again, turning it into a function. Some things that functions can do for us, again, accept input and return an output. It can be taken to other project files using the import keyword, which we will cover eventually. But the import keyword is very important. And they can have multiple versions for different purposes. So, it is possible to create multiple functions with the same name that take different inputs and produce different outputs. Say you have one that looks for integers and one that looks for floats. You can name these the same, and when you go to provide input during a function call, that input will determine which version of the function you're going to use. It's a little less useful in Python, but in languages like C++ and Java that have high amounts of type safety, this flexibility can be very useful. So, the way we create new functions is using the def keyword, def. This is short for define. So, again, let's do a quick rundown of parameters versus arguments. Parameters, if you recall, these are your placeholders. These tell the user what is expected of them. It could be things like X, username, hit points, things of that nature. Whereas an argument is the exact value that is given during a function call. So you can see we have some examples like the number 10 or 100, and of course JLK it can be a username as a string. These can also be variable names provided they have a defined value. So if you have a function that accepts a username, you can create a username variable and then pass that into the function call, as long as you are passing it a name that has an associated value. Some other key terms that you're going to come across in your study of functions. Again, a call. This is where we invoke a function, tell our interpreter or compiler to use said function. And again, passing, reviewing this again, this is when you hand a function some information, some input value, like the one seen in the previous slide. Now, some new terms here. We have pass by value and pass by reference. These are how we send data into a function, and most languages handle this for you under the hood. You don't have a way to choose it. C++ does have a way to select pass by value or pass by reference, and you'll see that in CS231. But for CS230, for Python, we are not concerned with how we can select our pass method. So pass by value is directly passing the variable itself, whereas passing by reference sends a memory address into the function and tells it, here's where to look for this value. Now, the question is, which does Python use? And this is a very hard to answer statement because Python doesn't use either of these in a strict sense. So, just to confuse you a little bit, Python uses pass by object reference, and object references are passed by value. So it's a little bit of both, which one it does. But is it necessary for you to concern yourself with this when you are coding? Not really. It's handy to know so you get an idea of how Python handles things, how data moves through your program, but it is passed by object reference, even if it is something as simple as an integer. And then again, we have return value. This is what is sent back to the caller of the function at the end of function execution. So, we're looking at this table again. This shows us how to define and call, pardon me, it shows us how to define and call functions with different numbers of argument. And you can tell these look the same. So, if you want to define a function with no arguments, 1, 2, or multiple, it looks the same. If you want to define or call a function with none, 1, 2, or multiple arguments, again, fine. There's one thing that I want to call attention to here. We have a fifth line when it comes to defining with default parameters. So if you remember, your print function has some default parameters, and any default, number one, go to the end of your call list, of your parameter list, and also they are referenced by name in both the function definition and the function call. So think about how end looks in your print function. Some other important keywords we have here. First off, we have return, which is always given some kind of value, or generally given some kind of value. Again, sends value back to the function caller and ends the function. Next, we have break. We saw how this works with loops. It terminates the containing loop. And it says here, immediately terminates containing, yeah. We have the continue keyword, which exits the containing loop and begins another iteration. So break and continue, like I said before, are very similar keywords. However, they have that one important difference, that a break moves on from the loop, a continue restarts the loop. And then lastly, we have pass. What this does, this is a null statement. It's used as a placeholder in the event that you want to create a header for something, whether it be a function, a loop, an if statement, or whatever, but you don't want to do anything yet. You are effectively saying, I'm going to come back and fill this in later when you use the pass keyword. Why not just use an empty code block? It has to do with how Python expects things to be written. When it sees a colon, it expects at least one line of code that is indented at minimum. If it does not get that, it is going to return an error. So, to make an empty code block, you just put the word pass inside of it. Other languages like C++ and Java, they rely on curly braces to define their code blocks. And of course, you can always leave a pair of curly braces empty, and it's not going to make a difference as far as the compiler is concerned. It's going to see inside that, no, there's nothing to do, and move on. So now we come to some examples just to get you thinking. In the next few videos, we're going to look at factorials again. We're going to do our own sum function. And we're going to do a mean and range function. We're going to do something that returns two values. We're going to do it using a collection. The last thing I want to talk about is lambda functions, and this is not going to be something you see much in your assignments. However, it is a very powerful tool in Python and some other programming languages. So it is a single line expression that creates an anonymous function. That anonymous function is then stored inside of a variable, and that is how we give it its name. So, of course, it can take any number of inputs, but it only evaluates one expression. So if you have an extraordinarily simple function like anything that, say, doubles a value or just evaluates one mathematical expression, then you may find yourself wanting to use a lambda function, as this will save space and it looks really neat when you do it. So that's going to do it for our talk on functions for now. Next videos, we are going to look at some examples. We're going to look at that factorial, sum, and the mean and range functions. So stick around for that.